Welcome to Start Venture. This class will learn about pair of linear equations with two variables. We will see the solving methods for the linear equations with the two variables. When we were studying polynomial linear equations, we studied about linear polynomial equation and graphical solving method. If you have not seen that video, I will recommend you to go through that video. I will give the link in the description box. Okay, so now let's see linear polynomial equation. That is y is equal to p of x is equal to ax plus b. This is linear polynomial equation. Why it's linear polynomial equation? Since maximum order for the variable is power is only 1, right? That's why this is called the linear polynomial equation or first degree or first order polynomial equation. How did you found the roots for this polynomial equation? Roots are zeros. When you are making p of x is equal to 0, that is ax plus b is equal to 0 we make, and then we found the roots for this linear polynomial equation, right? This one we have studied in the earlier classes. Now we see, we will take the same linear first order polynomial equation, that is y is equal to ax plus b. Okay, let's take this a into other side, that is ax minus y plus b is equal to 0. Okay, so if you observe this equation, we are not finding the roots for the linear polynomial equation by making y is equal to 0, right, earlier, but we brought that variable also into the same side and we written the expression as like ax minus y plus b is equal to 0. If you observe this equation, here we have the two variables, that is x and y. Okay, and we have the two constants a and b here. Okay, those are called the coefficients or constant, like, right, those are like real numbers. If you observe this equation, x and y are both are not independent numbers. You can see some example. I am writing a equations with two variables like this, x plus y is equal to 5, right? So here this is the two variable linear equation, right? When x is equal to 1, y must be 4. Why? It has to satisfy this equation. If we put x as a 1 number, y must be 4 to get right side number like 5. If x is equal to 2, y must be 3. Y 2 plus 3 is equal to 5. So what I am trying to say is we cannot enter the xy numbers independently. Okay, if we know the x, we can find the y, and if you know y, we can find the x. Okay. So how many points can satisfy this equation? This equation can be satisfied infinity points. For example, similarly you can keep writing like 3, 4, 5, like I am writing here now 6, x is equal to 6. What is the y number? It should be minus 1. So it is 6 minus 1, again 5. If x is equal to 100, what is the y? Minus 95. So 100 minus 95, again it's a 5. So like that, if you keep writing in the negative numbers also, like x is equal to minus 1. So any linear equations has the infinity satisfaction points. Right? I will show you some of the example for the linear equations. Okay, for example, you have 100 rupees with you. Okay, and you went to the market and you know that you will get the 2 kgs of apple for the 100 rupees. Some of your friend asked, okay, how many apples you get for the 500 rupees? Okay, so what you do immediately? You do 2 by 100 into 500, you will put it, right? Then you will get the answer as 2 to get cancelled. This is cancelled. Then you will get the 10 kgs. quickly we will say we will get the 10 kgs, right? How did you put this expression like 2 by 100 into 500 is equal to 10 kgs? That's what I'll give the little more explanation. Okay, why do we put it this way, this one this way? Okay, so you have changed this variation linearly. For example, 1 kg of the apples is 50 rupees, 2 kgs of the apples is 100 rupees, like 3 kgs of apples 150 rupees. So you are keep changing linearly these numbers. Okay, that's the reason you put it directly constant like 2 by 100 into 500, so that you are getting 10 kgs for the 500 rupees straight away. Okay, I will go some more in details to understand better. Okay, for example, in the same shop he has told that if you buy 1 kg I will give for the 60 rupees. Okay, if you buy 2 kgs I will give for the 100 rupees. Okay, but if you buy 5 kgs I will give it for the 200 rupees. If seller is saying like this, so this is the kgs, how many you get it, it is not varying linearly. Okay, it is changing its potential, because see here you are getting for 60 rupees 1 kg, here 1 kg you are getting for 50 rupees because 100 by 2. Okay, and here you are getting for 40 rupees itself you are getting kg. So this is not varying linearly. Okay, this relation. So in this, while changing this kind of expressions, if someone asks you how many apples you get for the 500 rupees, do you have answer for that? No, you cannot put it straight away this way. This way you cannot put the formula like 2 by 100 into 500, you cannot put it, because this is not changing linearly, it is changing non-linear. This is called non-linear, that we will study in the later of the classes, not required right now. Okay, let's see some more in details what we have taught. Okay, so let's take, you have x rupees with you. Okay, and you are getting the y kgs of the apples. Let's take you have the x rupees and you have the y kgs of the apples. Let's take, we have the linear relationship between the rupees what you get apples for the what the money you have, right? Then let's take the linear equation. Okay, general form of the linear equation can be taken as ax plus by plus c is equal to 0. Okay, this is a general form of the linear equation where we have the two variables x and y, and we have the one x coefficient and one y coefficient and one constant. Okay, let's take this is the linear equation. So what you know, if you have the x rupees, you have x is equal to, if you have the 0 rupees, okay, how many apples you get it? You get 0 apples, right? So you know 1 point for this line, right? Let's take another point. Okay, another point, what you know? You know that if you have 100 rupees you will get 2 kgs of the apples. So you know 2 points. Okay, from these 2 points we can find the constants in these equations. That's what x and y will keep it, and we need to find the constant of 3. It looks like 3 constant, but we have the 2 points to find out. But if you really rearranging this, so I will rewrite this equation into another form like this. Okay, I am keeping by is the one side. Okay, then sending other 2 terms to the other side, then it will become minus ax minus c, right? Then y is equal to minus a by b x minus c by b, right? Let's take a by b is another constant, that I am taking m for the time being, and c by b is another constant like c. Okay, so this is another c, not the same c. I am just saying this entire is a constant, one constant. Here is the a by b is another constant. So we can write the line equation or linear equation in one more form is y is equal to mx plus c. Okay, here we have the 2 constants need to be find. We know one point here, right? This is the point 1, x is equal to 0 and y is equal to 0. If we substitute x is equal to 0 and y is equal to 0 here, 0 is equal to m into 0 plus c. So from this equation you know c is equal to 0, right? If we put another thing, another point like x is equal to 100 and y is equal to 2, okay, 2 is equal to m into x is 100, right? So what is the m? 2 by 100, right? Then m is equal to 1 by 50. Okay, so let's substitute both m and c into the main equation. Okay, y is equal to, what is the m? 1 by 50 into x. Okay, c anyhow 0. So you got what is the y, how much money you have, right? Sorry, y is number of kgs of apples you get it, x is the money you have. Okay, for example, let's take x is equal to 50 into y. Okay, if you have x as 100 rupees, okay, if you have x is 100 rupees, how many apples you get it? From this equation y is equal to 100 by 50, you get 2 kgs of the apples. If you have 500 rupees, how many apples you get it? Y is equal to 500 by 50. So that is equal to 10 kgs you get, right? So that's the reason you are straight away putting the constant, that constant is 1 by 50, right? So when you are making right, initially also you are getting the same constant like 1 by 50. So I can write here like this, right? So someone says for 100 rupees if you are getting 2 kgs of apple, and 500 rupees, how many kgs of the apples you get? That's the reason we are putting 2 by 100 as a constant here, and then just simply multiplying with 500. Okay, the similar thing we did it, but we did more described and elaborate of the linear functionality of the equations. Okay, let's take a graph to understand better. Okay, so I am writing a linear equation here, that is x plus y is equal to 5. As I said, it has the infinity solutions. Okay, it has the infinity solutions, because by keep varying the x value for the minus infinity to plus infinity, you will get corresponding y numbers to that. Okay, if you substitute, it will be satisfying this equation. So for example, I will write x is equal to minus 4. What is the y? If you put into the above equation, y is equal to 9 you will get, right? So similarly I am substituting x is equal to plus 4, then what do you get? The y is equal to 1, right? So if you substitute, both x plus y is always 5, right? So I am just marking these 2 points into the line. Okay, see, x is equal to minus 4 and y is equal to 9. So when x is equal to minus 4, y is 9, that is when x is equal to minus 4, y is 9. Okay, this is the point. Okay, when x is equal to 4, y is 1. Okay, when x is equal to positive 4, y is equal to 1. Okay, that is another point here. Okay, so this is the one. Okay, so we just required to draw a straight line, only 2 points. Okay, now we take a scale and just join these 2 points. Okay, then you get the linear equation, right? So now we have joined the 2 points. This is the point is minus 4 and 9, and another point is 4 and 1. Okay, now let's take what is the value of x at y is equal to 0. Okay, when y is equal to 0, x is equal to 5, right? That you can see directly from the graph. You need not to be calculated the rest of the points. Whatever the points you want, you can just mark on the line and you can find out. For example, so this is the entire x-axis, y is equal to 0, right? So okay, so when y is equal to 0, what is the x here? You can see here, that is the point between the 4 and 6, so it is a 5, right? Similarly, when y is equal to -4, okay, what is the x? Okay, you can see here when my y is equal to -4, you can take this line and you can see here. So x is 9, right? So you are getting directly x value from the graph. Okay, like that you can find for any x corresponding y, you can find for any y corresponding x, you can find from this linear equation. Okay, so this linear equation has infinity satisfaction points along with the linear line. Okay, so this line equation is x plus y is equal to 5. Okay, and all these points are satisfying the equation. This is the reason we are writing general form of the linear equation like ax plus by plus c is equal to 0. Here a and b are the real numbers, so with each line having the different real number for this equation. So for the current equation, if you see, is x plus y and minus 5 is equal to 0 here. There a is equal to 1, b is equal to 1 and c is equal to -5 here. If you write the two linear equations in this form, okay, I am writing the first general form of the first equation is a1x plus b1y plus c1 is equal to 0 is the first line, and the second line is a2x plus b2y plus c2 is equal to 0. Okay, here why we are written general form is ax plus by plus c, right? So this is the one line. By keep changing the constants a, b, c, only we will get to the infinity number of lines. That's the reason we have taken two sets of linear equations, that is a1x plus b1y plus c1 is equal to 0. Another line is a2x plus b2y plus c2 is equal to 0. 2 represents the second line, 1 represents the first line. Okay, like that if you keep changing, we will get the infinity lines. Okay, right now we are studying the some pair of two linear equations. Okay, so what kind of relation can have these two lines? Okay, let's take the first line. Let's take a line. Okay, I am taking a line, and let's take this line is a1x plus b1y plus c1 is equal to 0. Okay, this is the first line I have taken. Okay, so how can second line can be for this? Okay, it has three options. First option, so I am writing the second line into another color, that's red. Okay, this is the second line. Okay, so the second line, so this is the another line, that is a2x plus b2y plus c2 is equal to 0. Okay, so this line can intersect at a single point to the first line. Okay, so this is one option. So the second option is the second line can go parallel to the first line. Okay, example, it can go parallel to the first line. Okay, that is another option. Okay, so that it never intersect both and it does not have the common solutions. The first line have the so many solutions along with that line, right? And the second line also it has so many solution along with that line, but both lines cannot have the common solution, right? Those are different solutions we have. Okay, so this is the second option. Okay, what is the third option we have? The third option, the second line also may be coinciding with the first line. Okay, so both is passing into the same line. So this option, so it has. Okay, so we have three options. So what is the first option we discussed? Inserting at the single point. Okay, intersect at the single point. Okay, intersect at single point. So what is the second option? It has the parallel. What is third option? Coincidence. Coincident. Okay, so we have these three options. Okay, so this line alone can have the infinity solutions. Okay, this line alone can have the infinity solutions separate, but do you have any common solution? Okay, that means both x and y's are same point can satisfy the both equations. If x and y are the same numbers, can satisfy the both equation. That we need to check for these three options. Okay, when intersecting at single point, so this is the second line, this is the first line, right? So it is intersecting at one point here. Okay, then this point will be satisfying this line as well as this line. So it has the one common solution. So when you are intersecting, we have one common solution. Okay, when it's going parallel, so both are going parallel and it never touches each other. Okay, so no common solution. Okay, so the coincident one also, both are having the just coincide to one another over another line, right? So it does also have the infinite solutions because all the points will satisfy the both equations because both lines are just coincide to one over another. Okay, that's why it has the infinite common solutions, right? So now we'll discuss how do you identify those two lines are intersecting at single point, or it's a parallel, or it's a coincident. Okay, let's draw a line. Okay, so if you have the two lines, how do you know that those are intersecting at single point? Okay, that means it cannot have the same angle from the x-axis. Okay, if two lines has the same angle, okay, this one I always represent the angle from the x-axis like theta. Okay, this line having the theta angle. Okay, I am drawing another line. Okay, let's take another line. Okay, so this is having angle, it has the angle theta 2. Okay, so the line 2 has the angle theta 2 and the line 1 has the angle theta 1, right? So if these two angles are the same, let's take both theta 1 is equal to theta 2 angle, then the two lines are parallel or coincident. Okay, if it is not equal to, theta 1 is not equal to theta 2, then it has the both lines will intersect at the single point. Both lines will be intersecting at the single point. That is the point of the intersection for the two lines, and it has the common solution. Okay, so to derive the some kind of relations between the coefficients and the constant, we need to derive with this angle find out. Okay, that's required little bit background of the trigonometry and other things. If you are really interested to derivations for the below expressions, please give the comment below. Okay, a1 by a2 is not equal to b1 by b2. Okay, then these lines okay will intersect at single point. Okay, these lines will intersect at single point. Here a1 and b1 represent, ratio of the a1 and b1 represent the slope of the first equation. Okay, and the ratio of the a2 and b2 represent the slope of the second equation. Okay, if those are not same, then it has the intersect at the single point and it has the one common solution. Okay, so how these two can represent the slope of the equation? If you want, I said right, we need the derivation for that. So if you are interested, I will explain in another video. Okay, so let's take another case, okay, where a1 by a2 is equal to b1 by b2. That means both equations slopes are same. That means it has the same angle. That means it is either parallel or it's coincident. Okay, either parallel or it's coincident. Okay, if this ratio is not equal to c1 by c2, then it is parallel lines, right? If it is equal to c1 by c2, then those are coincident. Okay, now overall I will write the single expressions something like this: a1 by a2 is equal to b1 by b2 is not equal to c1 by c2 is parallel lines. If a1 by a2 is equal to b1 by b2 is equal to c1 by c2 means these are coincident lines. If a1 by b1 is not equal to b1 by b2, you need not to check c1 by c2. Okay, these are the intersecting lines at single point. So how many common solution it has? It has the one common solution. Parallel means no solution at all. Coincident means it has infinite solutions. So okay, remember these three terms for the equations. Okay, this will be important. So any pair of linear equations has any common solution, any one at least common solution, those are called the consistent pair of equation. Okay, consistent pair of equations. Okay, if it does not have any common solution, like even single solution also it does not have, those are called the inconsistent pair of linear equations. Okay, so here we are telling then the coincident and the intersecting, these two are the consistent pair of linear equations we are calling, and whichever having the parallel and no common solution, that's called the inconsistent pair of linear equations. Okay, inconsistent pair of equations. Let's write the two equations. X plus 3y is equal to 6 and 2x minus 3y is equal to 12. So these are the two equations. We need to find these two equations are consistent, having the solution or not. Okay, let's take this is the equation 1 and this is the equation 2. Equation 1, this is the equation 2. Let's rewrite the first equation. Okay, it is x plus 3y minus 6 is equal to 0, and the second equation 2x minus 3y minus 12 is equal to 0. Okay, a1 is equal to 1, b1 is equal to 3 and c1 is equal to minus 6. In the second equation, what is the a2 is equal to 2 and b2 is equal to minus 3 and c2 is equal to minus 12. Okay, let's find the ratio. First you need to find the ratio. A1 by A2 is equal to B1 by B2 or not. We need to check this. Okay, we need to check. For checking, we are taking left hand side one, that is A1 by A2. Okay, what is A1 by A2? It is a 1 divided by 2. Okay, then right hand side one, let's take B1 by B2, that is 3 by minus 3, that is minus 1. So we have checked that A1 by A2 is not equal to B1 by B2. So these two lines are consistent and having unique single solution it has. Okay, while solving we need to identify in the graph 2 points and join them for the linear equations. Let us take the first equation. Okay, it is x plus 3y is equal to 0, 6. We need 2 points to draw a straight line for the linear equations. So we need to put it two numbers for the x, and we need to locate those points into the graph. You can take any points. It's easy to take x is equal to 0, right, and find the y, right? So that let's take x is equal to 0. What is y? Put the x is equal to 0 into this equation. So that we will get 3y is equal to 6. Then y is equal to 6 by 3, that y is equal to 2. So we got a data point either when x is equal to 0, y is equal to 2, right? Let's take, this is the one point. Let's take another point. Okay, when y is equal to 0. Okay, put y is equal to 0. What is x here? Then x plus 3 into 0 is equal to 0. So x is equal to 6. Okay, so we got another data point here. X is the 6 and y is the 0, right? So now we have the 2 points for this first one. Then we can easily draw line for the first equation. See, how do we draw here? Let's mark the points first. Okay, so what is when x is equal to 0, y is equal to? So this is the x is equal to 0 and y is 2. Let's mark the point 2. Okay, so this is the point, right? Okay, let's take with red color point. Okay, this is the point. This point is x is equal to 0 and y is equal to 2. Let's draw the point x is equal to 0 and y is equal to 2. Okay, let's take another point. When x is equal to 6, y is 0. Y is this, and then x is equal to 6. These 2 points are sufficient to draw a line. Then draw a line passing to these 2 points. Okay, this is the line, right? So this is the one line. What is the equation of this line? Keep writing the equation of this line always. Okay, so what is the equation of this line? It is x plus 3y minus 6 is equal to 0. Okay, let's draw similarly to the other line. Okay, what is another equation? Okay, see, the another equation is 2x minus 3y minus 12 is equal to 0. Okay, let's take x is equal to 0. Then minus 3y minus 12 is equal to 0. Let's take 12 into the other side of the equation. So we have 3y is equal to minus 12. Y is equal to minus 12 divided by 3. We have minus 4. So we have another point here where x is equal to 0 and y is minus 4. Okay, so let's take when y is equal to 0. Okay, then if we substitute y into this equation, we will get 2x minus 12 is equal to 0. So 2x is equal to 12 and x is equal to 12 by 2 and 6. So we have another point here, x is 6 and y is 0. Okay. So this case we got same point actually having the common solution, but you need not to get it like this. Okay. So how do you find is wherever the two lines are intersecting, that is the solution. Okay. Let's draw this line in the graph. Okay. I am taking another color here, blue color I am taking. So let's mark the first point. When x is equal to 0, y is minus 4. Y is minus 4 when x is equal to 0. So this is the point. Okay. What is another point? When x is 6, y is 0. Okay. When x is 6, y is 0. So this is the another point. Let's draw line passing through these 2 points. Okay. Okay. This is another line. So what is the equation of this line? What is the equation of this line? This line equation is 2x minus 3y minus 12 is equal to 0. So though individually this equation having the so many solutions along with this line, similarly this equation having so many solutions along with this line, but it has both lines are coinciding at one point. That means it has the one common solution, that is 6 comma 0. So x is 6 and y is 0, satisfy the both equations. So it has one common solution, that is 6 comma 0. Okay, this is the answer. Okay, so what we do, we need to find the 2 points from the each equation and we need to draw a line for the two lines, then it coincides at a single point, right? That point we are calling the common solution. Okay, for the both equations. So we have the one common solution for the pair of these equations. Okay, only this is possible when a1 by a2 is not equal to b1 by b2. So far we have seen the pair of linear equations. Okay, that is I am rewriting the pair of linear equation a1x plus b1y plus c1 is equal to 0 and another equation a2x plus b2y plus c2 is equal to 0. See, consistent and inconsistent. Consistent means at least one solution. Okay, consistent at least one solution is there, means those two lines are called the consistent pair of linear equations. So this is no solutions. Okay, no solutions. So when no solution is possible, when parallel lines. Okay, parallel lines, no solution is existing. Okay, here coincide. If both lines are coincide, it has so many solutions, or intersect at one point. Okay, so how do you find? We have seen, right, the two lines are consistent or consistent, or it's parallel, or it's coincide or intersect. We will find the ratios a1 by a2 comma b1 by b2 comma c1 by c2. Okay, so I said that a b coefficients are always related to the slope of the equations. Okay, if a1 by a2 is not equal to b1 by b2, then the two lines intersect at one point. Okay, intersect at one point. So these are the consistent. When a1 by a2 is not equal to b1 by b2, it's a consistent. If a1 by a2 is equal to b1 by b2, okay, and not equal to c1 by c2, then these are called the parallel. Okay, So this is inconsistent. Okay. If a1 by a2 is equal to b1 by b2 is equal to c1 by c2 means this is called coincident lines. So that is, it's a consistent and having the infinite solutions. So we have learned so far these things, and also we learned to solve the pair of linear equations through graphical methods. Now we will see some of the algebraic method for solving these equations. So algebraic methods for solving these equations. So there is there are the many ways to solve it, but we will be describing in this class two methods for solving the pair of linear equations. One is substitution method, So now we will see an example. Okay, I read pair of linear equations and I will solve these equations by using the both methods. Okay, let's take one pair of linear equations. 7x minus 15y is equal to 2. Okay, x plus 2y is equal to 3. Okay, these are the two linear equations with the two variables. Okay, so let's see, we have the how do we solve these two equations by using the substitution method. Okay, so I am rewriting the two equations in the substitution method one more time here. That is 7x minus 15y is equal to 2. Okay, and x plus 2y is equal to 3. Right, now let's take this equation is 1. Okay, let's take the equation 2. Okay, so what you do, right, from the first equation we will write either x or y separately and we will substitute that into the next y. Okay, so that we are indirectly eliminating the one of the variable and finding the another variable. Let's see how do you do that. Okay, from the first equation can write it 7x minus 15y is equal to 2, right? So either x or y will keep it one side. Okay, let's take, we will keeping the x is one side, that is 7x is equal to 2 plus 15y. Okay, what is the x? X is equal to 2 plus 15y divided by 7. Okay, so let's take, this is the equation number 3. Okay, that means reframe this equation number 3. Okay, now what you do, first equation we simplify it to this equation, right? So now equation 3 will we will put it into equation 2. Okay, so if you substitute x into the equation 2, okay, that is 2 plus 15y divided by 7 plus 2y is equal to 3. Okay, let's take LCM here 7. Okay, in these two, so then here it become 2 plus 15y plus nothing but here, see, LCM means this 2y will multiply 7 by 7 here, so that both have the same 7 diameter. We are taking 7 here, right? So it become 2y into 7 is equal to 3. Okay, further simplifying this, 2 plus 15y plus 14 y is equal to, we'll send this 7 to this side, 21. Okay, then further we are writing, simplifying this equation, 15 plus 14, 29, right? So 29y is equal to, I am sending to other side, so 21 minus 2, that is 19, right? So we have y is equal to 19 by 29, right? So this y value, if you put it any of the equations like 1 or 2, okay, you will get the x. Place y value into equation 1 or 2, anything is fine. Looks, this is like easy expression for finding x, right? That's why I am putting y value in equation 2. Okay, if we substitute y value in equation 2, let's see, x plus 2 into 19 by 29 is equal to 3. So x is equal to 3 minus 19 into 2, 38, right, divided by 29. Okay, that's equal to 29 into 3 minus 38 divided by 29. So 87 minus 38 divided by 29. How it is? If you want to multiply, always write 29 into 3. Okay, it's difficult to multiply. So what you do, you just multiply 30 into 3. Just we added one number, right? 30 into 3, 90. That 1, you write 1 into 3 is 3. You need to subtract. Okay, because we increased the one term here like this. So then we get the 87. So 90 minus 3 is 87 actually. Then minus 38. Okay, then we can see 49 divided by 29. Okay, now by using the substitution method, we found the x and y. Okay, x is equal to 49 by 29 and y is equal to 19 by 29. Okay, so this point, these two equations will be satisfied with this point. Okay, that means these two lines will intersect at that point. X is equal to 49 by 29 and y is equal to 19 by 29. Okay, so now we see the same problem with elimination method. Okay, how do you solve the elimination method? So I am rewriting the same equations once more time here. That is 7x minus 15y is equal to 2. Okay. So another equation is x plus 2y is equal to 3. Okay. So first equation I am rewriting into the ax plus by plus c format. So 7x minus 15y, I am bringing y to other side, that is minus 2 is equal to 0. So another equation is x plus 2y minus 3 is equal to 0. So let's take this is the equation 1 and this is the equation 2. Okay, so by adding or subtracting or multiplying, do anything for these two equations. Okay, we need to eliminate one of the variable so that we can find the other variable. Okay, if any equation we have the two variables, we cannot find, okay, until we have another equation. Okay, so what you do, right? So in the previous substituting method, what we did, we have taken one of the variable to one side and we substitute that variable into another equation so that entire equation will become with a single variable y. Then we find the y. Then again re-substituting the y value from the original equation, we find the x, right? Similarly, what you do here, right? We will eliminate the one of the variable. We can eliminate either x or y. Anything we can eliminate. Okay. How do we eliminate? Let's see what I do. Okay. I am rewriting the first equation one more time here. Okay. So this is the equation 1. Okay. So but equation 2, what I do, I will multiply the equation 2 with 7. Okay. So multiplying entire equation left hand side and right hand side with any number and adding any number either side, divide with any number either side, will not change anything, right? That's what we know. Okay. So from that I will be multiplying with 7 with this equation number 2. That's where I have written 2 multiplied with 7 number. Then what will become? It becomes 7x plus 14. 7 into 2 14y minus 7 into 3 21, right, is equal to 0. Now what I do, for assuming that we have the same x and y for the both the equation, that's where it's called the solution. So we are eliminating from these two equation x term. That's why we make the x coefficient same for the both equations. Now I will be subtracting equation 1 minus 2. Okay, writing example like this, 1 minus 2. Okay, then we are putting minus here, minus will be changing plus, right, when you are subtracting. So 7x minus 7x is 0. So minus 15y minus 14y. This is the first term. The second term is minus 2 plus 21 is equal to 0 plus 19 is equal to 0. Sending to the one side, 29y is equal to 19. Y is equal to 19 by 29. Right? Now similarly to like last example, y is equal to 19 by 29, will substitute, will put it into equation number 2. Okay, so if we add that one, so x plus 2 into 19 by 29 minus 3 is equal to 0. If we simplify this equation, we will get x is equal to 49 by 29. So now the solution is x is equal to 49 by 29 comma y is equal to 19 by 29. Okay, so at this point will satisfy the both the equation. It has, so both lines will intersect at the point x comma y, that is 49 by 29 comma 19 by 29. So at this point these two lines will be intersecting. Okay, that means it has the common solution, right?